Welcome to Math Studio Talk. The purpose of these videos is to help you interpret what students should be able to do and understand to meet the demands of Common Core Math. We will demonstrate various games, activities, and models that can be used within the structure of a formal lesson plan to develop flexible thinking and deep understanding. And of course, we'll show you the math. Hi, I'm Nick Timpone. In this video, I will deal with the number and operations in base 10 domain and the number and operations with fractions domain for 3rd grade, which builds from the work done in the NBT and NF domains of 2nd grade. As you can see, students will extend their knowledge of place value and the properties of operations and develop an understanding of fractions as numbers. Let's begin with Standard 3, NBT 1. This standard specifies using place value understanding to round. Fortunately, the in-depth place value work students did in grades K to 2 have them set up to learn this standard without much difficulty. The algorithm of looking at the number to the right of the number you are rounding to and rounding up if that number is 5 to 9 and rounding down if that number is 1 to 4 is hard enough to say, never mind remember. That is why we will use place value understanding. Let's consider 78 to the nearest 10. The question the student has to be able to answer is, what two tens is 78 between? What two tens is 78 between? 78 is between 70 and 80. Place 78 on the number line. Approximate. Is it closer to 70? Or is it closer to 80? Oh, well, it's closer to 80. So 78 rounded to the nearest 10 is 80. It's as simple as that. And it uses their place value knowledge and reinforces that knowledge by thinking about what two tens a number is in between. Let's look at 71 to the nearest 10. Again, what two tens is it between? 70 and 80. Place it on the number line. Approximate. 71. What number is it nearest? It's nearer to 70 than 80, so 71 rounds to 70. In the case of rounding 75 to the nearest 10, we're still asking the same question. What two tens is it between? And that's 70 and 80. But in this case, 75 is exactly in between 70 and 80. By convention, we round up, so 75 rounds to 80. Now let's consider the case of rounding a number in the hundreds to the nearest 10. This is a little more difficult because you're not thinking between the two hundreds, you're still thinking between the two tens. So the question we ask, if we're rounding 234 to the nearest 10, what two tens is 234 between? 234 is between 230 and 240. When you get to this point in teaching the rounding, it's often good to find the midpoint to make it easier to place the number. So let's ask the students, so what number is directly in the middle of 230 and 240? 235. Now, when they have to place 234, they'll understand that it's to this side of 235. And they'll round down to 230. You would never round a 4-digit number to the tens place. It really doesn't make any sense to do that, but you might round it to the nearest 100. So let's look at 2,478 to the nearest 100. The question again, what two hundredths is 2,478 between? It's between 2,400, 2,500, and again, let's identify the midpoint. It's all good practice for place value. What's exactly in the middle of 2,400 and 2,500? That's 2,450. Now, when we have to round 2,478 to the nearest 100, we know it's going to be on that side of the midpoint. 2,478 rounds to 2,500. Rounding is really important in math because it makes it possible to estimate and to consider whether an answer to a computation is reasonable. In fourth grade, students will learn to round any whole number to any place. And on to Standard 3, NBT 2. Third grade is the first time that the standards mention using algorithms for adding and subtracting. An algorithm is any set of steps that can be used for a certain type of problem that will always give the correct answer if followed precisely, such as the vertical algorithm we are all familiar with for adding and subtracting. Please note that it is not until fourth grade that students are expected to become fluent with the standard algorithm. We will introduce the algorithm in third grade simply by showing that the numbers we are adding can be stacked vertically instead of horizontally. However, we will still be emphasizing the strategies based on place value and properties of operations that students began working with in second grade. Let's look at some ways students might solve this problem. Let's look at decomposing as a strategy. 219 can be decomposed into 200 plus 10 plus 9. 386 can be decomposed to 300 plus 80 plus 6. Now, instead of dealing with multi-digit addition, we're really only dealing with single-digit addition in each of the place values. 2 100ths plus 3 100ths is going to give you 5 hundredths. Now let's put the tens together. 1 10 and 8 tens put together will give you 9 tens, which is 90. With the ones, we have 9 ones and 6 ones. That gives us 15 ones, which the students understand as 1 10 and 5 ones. Now let's continue. Now let's put this number back together again. 500 plus 9 tens and 1 10 gives 10 tens. Students understand 10 tens as 100. Plus 5 equals 5 hundredths, and 100 equals 600, plus 5 equals 605. This is a really interesting way to solve these problems, and it gives the student more practice in place value, expanded form, and addition. Another way this problem could be solved is as jumps on a number line. Where are we starting? We're starting at 219. What would I like to do my first jump? Well, let's look at the number we're adding, 386. 219 and adding 300 is not a difficult problem because you're only dealing with 3 and 2. The 19 is staying the same. So jumping 300 from 219 is going to get us to 519. Now I have to do the tens place. I have to jump 80. Well, that's, again, not hard because I'm doing 8 plus 1. The 9's just coming along for the ride. So this becomes 599. And now I look in the ones place. I have to jump 6 from 9. I'm going to use making tens that we learned in first grade to know that's 1 to 600, and 5 more gets me 605. Of course, there are other strategies for solving these problems, and students should be given the time and freedom to come up with them. The first and second grade standards for this specify using drawings and models, whereas that language is left out in third grade. So students should be using place value knowledge and properties of operations only. However, using number lines and base 10 blocks to help struggling students understand the more abstract strategies is okay. In fourth grade, students will be expected to add and subtract exclusively with the standard algorithm. Okay, on to Standard 3, NBT 3. We want students to thoroughly understand this standard and not just learn that you multiply the non-zero digits, then add the 0 back. Let's look at it using arrays. Students recognize this as 4 groups of 3 ones, which is 12. Then we can move to this one and see that this is 4 groups of 3 tens, which is 12 tens, which is 120. Now we can move to this statement. 5 times 60 is 5 groups of 6 tens, which is 30 tens, or 300. The work in this standard helps students see the special property of 10 in the place value system. This will be helpful in 4th grade when they will have to understand and explain why a digit in the ones place is 10 times larger than the digit to its right. Okay, let's look at standard 3 NF1. This means that the student needs to understand 1/5 is one of 5 equal parts of a whole, and that 4/5 is the quantity generated by putting 4 1/5s together. We begin with a unit fraction, which is a fraction with a numerator of 1. In 2nd grade, the students were introduced to this concept in the geometry domain. Paper folding is a great activity for understanding fractions. Give the students a rectangular piece of paper and ask them to fold it in half. Then ask them to fold it in half again. Then have them open it up, and let's have a discussion about how many parts we have. Here is a whole. How many parts? 1, 2, 3, 4. What do we call each of these parts? 1/4. Have the students label all of the sections 1/4. Let's move on to standard 3 NF2. This is an extremely important standard because we are switching from fraction as part of a whole to fraction as a number that can be located on a number line. I've drawn a number line here underneath the bar model that we used previously. We can have students identify the fractions that go on the number line by using what they learned previously with the bar model. 0 to 1/5 is 1/5. 1/5 plus 1/5 is 2/5. This is just like the activity they completed before. 2/5 plus 1/5 is 3/5. 3/5 plus 1/5 is 4/5. And 4/5 plus 1/5 is 5/5. And there they'll also see that relationship as 5/5 being equivalent to 1. Now they can make the comparison as fraction as part of a whole and fraction as a number on a number line. On to standard 3 NF3. A lot here, so let's get started. 3A and B concern equivalent fractions. We will not teach the students the algorithm. They will only find equivalent fractions by using models and number lines. Using blank fractional number line sheets is a great activity to teach equivalent fractions. With these number lines, students have to understand what the fractions are. So they see this is a whole. They see that this is broken in 2, so this has to be 1/2. They see that this is broken in thirds. This is 1/3, and this is 2/3. So they go through this entire worksheet and fill in all the fractions. And what they end up noticing are things like this. This is 2/4. This is 3/6. And they can see that they're on the same location on a number line. In that way, they will develop the understanding that if they're the same place between 0 and 1, they're equivalent fractions. 1/2 is equivalent to 2/4 is equivalent to 3/6. So they'll fill out this entire sheet, and there's a lot of things you can do with this. They can also see now that 2/2 will be 1, 3/3 is equivalent to 1, 4/4 is equivalent to 1, and so on. Fractions with the same denominator are easily compared because it makes sense to students that the more parts you have, the bigger the number. 4/5 is greater than 3/5. Fractions with the same numerator are more difficult to compare. Comparing fractions activities can really help students understand this. Give students a set of fractions using these fraction circles and ask them to put them in size order from the smallest to the largest, just by how they look. So they'll compare, they'll put them next to each other, they'll work around, they'll move things around, and they'll finally get it into this configuration. And then we have a discussion. We talk about the fractions: 1/8, 1/6, 1/4, 1/3, 1/2. What's happening to the denominator as we're moving up to a larger size fraction? The denominator is getting smaller. As the denominator of a unit fraction gets smaller, the size of the fraction gets bigger. This takes time to develop. Lots of activities with this and other activities will help the students develop that understanding. They also have to understand that when comparing fractions, the size of the whole is important. For example, half of a large pizza is greater than half of a personal pizza. Building this fraction foundation is extremely important, especially the understanding of a fraction as a number, which is much harder for students to conceptualize than the part of a whole understanding of a fraction. Thanks for watching this Math Studio talk. We hope that you enjoyed it, found it meaningful, and learned a thing or two to take back to your classroom.